Hi, everybody. I am Jim.
I'm Vlad.
So today we're going to talk about coding an MCP server for Amazon Aurora. For those of you that have never been to a code talk, this is going to be a little different. You're going to sit here and watch me code for the next hour, right? I'm a bad typist, giving you that heads up right from the beginning. So I'm going to use Kiro to do a lot of the stuff for me. Otherwise, you'd be watching me having typos constantly. But let's keep this interactive. Let's turn this into a giant paired programming exercise. So if you see me making typos, shout it out. It's okay. I won't be offended if you see me making a typo. It'll make things go faster. And if you have questions, let's have them as they're coming along. Vlad's going to be walking around with the microphone. So let's just keep it interactive while we're doing things. So what we're going to talk about today is MCP. It's already Tuesday. You probably have had a few sessions about MCP, Model Context Protocol. This is a universal framework in order to be able to expose out your back-end data to LLMs, for Gen AI. It is still a new and maturing specification. It's only a year old, got released about a year ago. The latest spec just came out last week. Haven't had a chance to deep dive on it, but there's a lot of cool security stuff in there that I'm excited about because I thought that was something that was missing before as we were thinking about how do we push this into production, into exposing things externally outside of your internal infrastructure. We're going to leverage one of the AWS MCP servers, the Aurora Postgres MCP server. There's a bunch of them around a lot of different services. They're all on GitHub. Feel free to download and play with them. MCP really is made up of a bunch of tools. You're exposing out a bunch of services out to the LLM, and it gives you an API in order to be able to do that, and it's more in free text, right? So really, how the LLMs determine what those tools do is by the code by the description that you type there in human readable format. What you type there really matters in a lot of cases. We're going to use Aurora Postgres. So when we talk about Amazon Aurora, we have Aurora Postgres, Aurora MySQL, and Aurora DSQL. We're going to focus on Aurora Postgres. But the stuff we're going to do today really would work across any of the Postgres variants, even open source community Postgres. We're not doing anything specifically Aurora. Some of the MCP server stuff uses the data API for it, but the code we're writing is really Postgres code, not necessarily Aurora code. We're going to leverage Bedrock. Again, this is probably something that you're seeing in a lot of sessions this week. But we're going to use Bedrock to be able to host our models. So what we're building, we're going to start with a real basic Strands application it's going to be an entertainment hub. Right? And then we're going to build an MCP server that has two tools in it. It's going to have a tool called Get Movie Characters and Get Actor Roles. Those are going to pull data from an Aurora Postgres database. And then Strands is going to use Bedrock for the LLM in order to be able to use that data. The MCP client we're leveraging from Strands, right? We're going to start with a simple time MCP server, so we can tell what time it is. Those are one of those sample MCP servers that actually end up becoming really, really useful because LLMs don't know what time it is. So if you start asking questions about time, it needs to know what the current time is for different things. So if you wanted to say, show me all the log history for the last hour, it kind of needs to know what time it is for different things like that. So it needs a source of truth for that. So it ends up being fairly useful for a lot of different things. We're going to use a data model. This is from the IMDb data set. I created a data model that's more of a traditional normalized data model, foreign keys, something that you would expect in your old school legacy OLTP databases. So there's going to be some joins, right? So this way, it's not just the simple single table. It needs to think a little bit in order how do I get this data out. And it's some of it's ugly data, right? Of just being, how does it get out? Like when certain things are null, what does that mean? Because that's real life with data models that's evolved over a period of time. Instead of rolling out new columns, sometimes people change the meaning of those columns as they put in new data into them. And we're going to focus on securing our database, making sure that we do this in a secure way. Because it's, you're opening up your database to an LLM. Me, as an old school database person, that scares me. So I want to make sure that we're doing this in a secure way. And different things that we could put in along the way to make sure that what it's doing with the data is only what you intend it to do. So that we don't want it to be able to just query everything and post it out to the internet, that if somebody has some prompt injection attacks, how do we protect from those sort of things? So let's start writing some code. All right. So this is our application. Right? So we won't be in this screen very much. So this is just the basic thing. So just a heads up, right at the end of the session, I'm going to put a QR code to a GitHub repo that's going to have all the code that we're going to write today. So this way you guys could go download it. I'll upload it when I get back home after reInvent, probably on Monday, right? But I'll post it all there. But this way everybody will have the link for it, right? So let's just kind of show you a little bit what it is. So the simple Streamlit app. So it has a simple login page, nothing crazy. So we have a list of movies, all right, and then we have our MCP server there. What time is it? And if we have a decent internet connection, everything's going to sit there, returns the time. So that all seems to be working just fine. Okay. Now our data model here, this is our list of tables. Primarily what we're going to be looking at is the titles table. That has really all the information in there. So it has a handful of columns in there, has a primary key, a title type, the title, start year, end year, a bunch of indexes, foreign keys, right? The other thing that we have here is on this, I added descriptions for everything that's there. Inside of Postgres, using the comment command here, we could put in a description that's there. The MCP servers can use that in order to have the right context of what's in there. So that's something that, when you're working with developers or DBAs, everybody kind of knows what's in all the different columns. So we need to be able to share that knowledge with the LLMs. Using the native tools inside of Postgres that allows you to put comments and everything, lets you really be able to jump into and do that. So like you have things like here, end year, like only TV series is going to have an end year. It's null for everything else. So having that sort of information in there, so this way the LLMs know about it. Or this one here, the TS vector for the full text search for Postgres, putting a description of what it is and even how to use it. Right? So this way the LLM knows how to use that sort of column. Right? So outside of just for LLMs, that's a great way for sharing that knowledge with developers. If you need to be able to tell everybody what's in your schema, use comments. We put it inside our source code. Put it on your database objects too. You could put them on inside of Postgres. You could put it on basically every type of object. Use it. Right? So let's start by creating a. There's a little lag here with the internet. So we'll go create that. So we're going to use Kiro to do all our heavy lifting today. And we have a couple MCP servers that there we go. So there's some built in. we have the Postgres MCP server, and we have the weather MCP server, just as something to be able to do it, make sure that MCP is working. What is the weather in Vegas? And the cool thing about Kiro, it actually asks you whether or not you want to do a lot of operations. It's based on whether or not it's trusted or not. So it returns back the weather, right? Cool. The MCP, that you could have weather and you could have Postgres all in the same thing, right? It'll be able to determine kind of what you want to do. So I could also say, what tables can I query? It's going to think for a second, and then it's going to say, hey, can I run this off the information schema to get the list of tables? Right? I'm also doing this to build up a little context for Kiro so it knows what tables that are there. Right? So those are the same tables that we're seeing inside of Postgres when we look at it, that it's there. So let's start with, for me, being a database person, whenever I'm writing some sort of function or whatever that has to pull data from the database, I start with the query. Right? When I'm using tools like Kiro or other ones, I tend to use it the way I code, in the same order, in the same chunks. So I start with writing the queries, and then I start building around that. Write a query that returns all of the... Hopefully the LLM could get that typo, right? Otherwise, like, my OCD would drive me crazy for some of these things. All the characters and the actors who played them for a given movie title. So now it's going to ask if you could see the schema. So I'm going to So this is using one of the built-in MCP tools to get table schema. It's going to get the table definition. So I'm going to trust that because it's a query that I know and I trust versus just being able to run a random thing. So,
big question.
Yep.
Is that actually calling an MCP server from Kiro?
Yes. Yes, it is. So
that is not related to our effort of pulling data from movies and weather, right?
No,
weather and movies are part of our build, and then what you're doing is the IDE portion that's reaching out to the database through a database-specific MCP server.
Yeah, it's using the Aurora Postgres MCP server that I have pre-configured connecting to my database. So I gave it the connection string, user ID, password. So this way it's all set to connect to that database in my development environment. Right, so it's kind of pulling it live, right? So it produced a 4-table join here using the full text search that we're talking about, right? So we could say test the query. Right. And it's going to go run it. We want to run it, sure. You notice there's a little latency as it's kind of going there. So if you're thinking about doing kind of text to SQL, keep that in mind. So queries worked, right? It's like, here's an improved version that's going to pull out some of the JSON elements. We don't really want that, right? But the other thing to think about is it's doing a full text search on the name, but the Godfather has multiple things. They got Godfather, Godfather 2. We can forget about Godfather 3. We'll pretend that never happened. But it will return multiple things that's coming along, right? So, let's make it so this way it only pulls one particular movie. Sure. Trying that. It's going to do an explain analyze. and it'll show you the results that explained while they're there. So a lot of times what I'm doing, if it's running slow, I'll ask it to do that and say, suggest ways to improve the query. It's pretty good at doing that and analyzing Postgres explain outputs. Right? So it says it's using a GIN index and a primary key index. Right? So let's change the query to only return the most popular title if or multiple matches. Let's see what it does with that. So it wants to check the ratings table. And it's going to put it in there as a subquery. Right? I don't like the fact that it's doing a full text search twice. So let's have it to only use full text search once. So now it's going to do it as a CTE. So it could do pretty sophisticated queries, but you need to work with it a little bit in order to kind of massage it to get to what you want. But that's the same way that I would write a query. It's like you write something to kind of get the data, and then you switch it around, optimize it. So let's just test it again. I never trust when it's going to run SQL directly if I don't know. So I always wait and check to make sure, because sometimes it does weird things. Right? So it works. So write the query to a... So what I'm doing is I'm saving that off, that context, so this way we could use that later. One of the things about using these tools, if something happens and you lose your session, right, it loses all the context that's there. And we want to, as you're doing things, you want to build things up, save it off for a little while, be able to use that again later, right? So as I finish one little piece of it, it's like I want to save off that file, so this way I could use it as we're building up the bigger solution. There's a lot of tools. We saw them in some of in the keynote this morning about being able to do it in a much broader thing. But as you're kind of learning and being able to, you start using these tools, it's a lot of times using it the way you would normally code and do it that way, it's a lot easier to start being able to learn how to do those sort of things. And it's taking a really long time to be able to just write out a simple query. This happens sometimes, probably if you have a whole bunch of people who also using Kiro in one of the workshops or something like that. We have 60,000 people here, probably all playing around with Kiro all at the same time. Sorry?
Where's this MCP server hosted?
Right now, it's just in a subdirectory from my application. It's local, yeah. So,
No. The MCP server does not call an LLM by itself. Kiro, absolutely, yes.
yeah.
And one more thing, how do you preserve the session? So day one, you come and do this, and then at night you go speed, and then
Come back day 2, you want to preserve the session. That's what you were saying, right? How to remember the session in Kiro itself, right?
Yeah.
And what did you do specifically to save that?
This one, I just told it to write the query to a file, right? So the prompt I gave it was write the query to a file called query1.sql, right? So this way, it's just saving off the query that we built.
So the plan here is that if you're building it in multiple days, this one, you just leave the Kiro IDE open.
Yeah, for the way that I'm using it now, using the CLI, there's other more sophisticated tools that have longer-term memory. Maybe Vlad knows some of the ones. He tends to use those things a little bit more than I do. I'm going beyond VI right now, so this is sophisticated for me.
You're using the Kiro IDE, then you do have access to multiple sessions, threads, and are able to switch between them and keep different contexts for different tasks and so on.
So we're going to write our other query now. Write a query that returns all the roles and the movie titles for a given actor. and it had its context before, so it's writing a query a lot faster using that same sort of thing, but we also put that in the comment there. So this way it knows that I'm thinking it should use that. So we'll test it again, make sure that's all working. Things usually work, but sometimes it makes some syntactical changes, little typos. Sometimes it goes off into some weird loop. Right. It all depends really on what the context is. It seems like it's right now it's trying to figure some things out because it's trying to run it multiple times.
That we are building, the MCP server that we are building, that is, your plan is actually to write a SQL and then wrap it in the MCP as a name function, right?
Yep.
And give a description, and that's how LLM is going to know, hey, if I want to have movies, movie list is your MCP server's target definition or something like that, and then you have a SQL behind it.
Yeah, exactly. So we're going to write those two tools, and so we need two SQL queries. Each one of those tools is going to pull data from the database. I've always done database stuff, so I think in terms of write the query first and then wrap it. Other people start with the API, right, and then figure out the other direction, right? That's just the way that I tend to code. Others people think about it differently, but you could do it either way. But that's just the way I'd rather do it.
When you have the next break, I'll ask my next question.
Sure.
Follow-up question as well.
So it seems like there's something wrong here with the connection, so I'm just going to write the context out.
What Jim is trying to do here is essentially called the canned query pattern.
Yeah.
So
that.
we're essentially taking queries, wrapping them into tools, and they become deterministic tools. That with the Aurora MCP server, you can always ask it by hand, hey, give me this data from here, here, and here. But what's happening behind the scenes is the MCP agent's going to think about trying to discover the schema, figuring out what tables to ask, what joins it might need to make, and then come up with a query. That query may work or may not work. It'll test it. So you're going through a lot of agent loop cycles just to find the right query, which works if you're just doing data exploration, right? But if you're writing it for a front-end application, you probably don't want that type of a complexity, let alone latency. So the application is going to call predictably a certain set of deterministic queries. So let's take those queries, wrap them into tools, and then expose them to the end users. And that's what we're trying to do here. But we're starting with the queries.
Yeah.
So one way to do it is to expose it as tools, right? So each and every query that you need, you want to expose it as tools. The other way is, why can't you basically say, these are the tables that are available, along with the metadata that he already had, right? And then let the LLM decide how to join those.
You absolutely can, but there's two practical implications there, right? Who are the users of that tool? If it's you or Jim in front of there, then he can afford to go in and, let the LLM figure out the query. That's perfectly fine, right? That's the purpose here. Now imagine there's 10,000 of Jims sitting there and doing that. At that scale, does that make sense anymore, right? No, because then you're consuming a lot of tokens. It's going to be very, very costly for you to offer that capability. But if you know that the people are always going to ask the question about the actors, go ahead and take that query, wrap it around into its own tool, and it's always going to call that single tool. It doesn't need to go through multiple loops of the LLM. It doesn't need to consume extra tokens. It doesn't need to wait and have extra latency. So there's a trade-off there, right? But what Jim is doing there is giving him flexibility to design the right tools. But if this would be an agent that I would be using as a consumer, that wouldn't be cost effective for whoever is operating that service. So Jim is building the tools for me, essentially, as a consumer.
You can basically say with the default local MCP server, you can let it query the schema and say, write an MCP server, because that's also an LLM, right? Write an MCP server, look at these tables, but have the tools defined as one for movie and one for actors. Write an MCP server with 2 tools, right?
Yeah, you can absolutely design that way, or it can be 1,000 queries or tools. It doesn't matter, right? It's the use case.
There is an optimal runtime that the tools can run.
Correct. Yeah.
So writing a prompt now to really write the MCP server. So I'm telling it I want to have 2 tools. I gave it a reference to the weather MCP server as a template. It does a lot better if you point it at something of what you basically want to look like, right, in order to do that. Telling it to connect to the database using PsychoPG3, use the queries that we generate as templates, and then we want to load the connection information from a file called .env. Now it's going to think about that for a second, and it's going to want to go check that tool, that other MCP server, so it can see what's there. It's going to go find those queries. Now it's going to build that MCP server, writing a lot of Python code a lot faster than I could do it, right? Then I could type it. Right? So this is what it's given us, right? It's movie server, creating a database connection. Right? It's only getting the database URL. We need to change that. Right? Here it's pulling in that query that we had. Right? Here's the other one, pulling in the other query, right? And then it's the same thing. So let's tell it to change the get DB connection. Like user and password instead of a full URL. I'd much rather have distinct things, so this way you have to go change a password, right? Or you should do this thing instead of having the full connection string. It's just the way I'd prefer it. So let's see if it did that right. Right, there we go, right? Pulling that all together that way. So we say, yeah, let's save that off. So now we have this movie server. We'll copy the .env file here. And let's get out of here and let's test that out. Yeah, gotta go up one more. Now, if we could go through this whole session with this thing producing no errors, it would be the first time ever I've run through this thing, right? So I'm anticipating something going wrong, right? Especially since it's, things are non-deterministic. As a database person, that drives me a little crazy, right? Because you don't know what you're gonna get. So let's see in Star Wars. And because it knows what Star Wars is, it just pulled it off of the internet, right? So we didn't fix. We need to be able to tell the user app to be able to use it. Let's go back to Kiro here. Change. factory. So the way I tend to interact with these things, with the prompts, is just the same way as if I was talking to somebody next to me and trying to like have them code for me, right? Assuming my fingers weren't working, if I was going to have somebody do it that kind of knows how to code a little bit, right? And extracting them, it's like it tends to work.
So you're a backseat coder, basically.
Yeah, it's that's definitely what it is. I'm really embracing the two-person coding rule there and having somebody else do all the typing. As everybody's seeing, I'm a terrible typer, right? So now we're adding that in there. Added that second MCP server. All right. So now let's go try that again. But that's kind of how we're using it too, even inside of RDS and how everybody's starting to use these tools. It is kind of a paired programming thing for a lot of people in order to really accelerate your development program. Now let's see if we can find that tool. There we go. Found the tool. Get movie characters. So it's running the query in the background, right? Gets back the list of them there, and then it displays it. So that's something there that is out on the internet. So it's not really showing anything because it is kind of public. So let's go create something there that's not there, right? So I have this simple app here called admin. Instead of you watching me write a bunch of stuff inside of SQL, just this basic thing over top of it. So let's create a new movie called DAT429, coding in MCP server. And we'll make this a TV movie. We'll add a person. Let's add Jim. Come on. Go. No, there we go. And let's add Vlad. Now let's put them in that movie. Jim. Everybody in the Postgres community calls me Jimbo, so that's the character name. And let's go Vlad. And we got Mr. Vlad over there in the back with the microphone. So now we have a movie there that's not out on the internet. Right. And I just killed my session there. Right. I don't know, Streamlet's still running. It is. Let's kill this sucker. Let's see if we could go find that movie that we just created, because that's only going to be in our database. Right? Same as if you had your own internal stuff that's not, the models haven't been trained on, right? Who is in the movie DAT429? Boom. Was able to find that. So this way, it had enough reference there to be able to know, hey, it's a movie, the movie tool, so this way you could get that. It doesn't have to go out the internet to get it. It's pulling off my local database. So even though we're using public information there, a lot of times you want to build these tools, these MCP tools, using your own internal stuff that you're not training public models on, but you still want people to interact with, right? but how do we secure this stuff, right? This is still, if you're putting this out on the internet, right, or if you want to be able to do that, you want to be able to secure that a little bit better, right?
One comment I would make there is the LLM is not necessarily going out on the internet and doing a search. So whenever Jim searched for Star Wars was part of a training data set for the model itself. So when the LLM got invoked, it figured that it can answer that question directly without invoking any tools. So the first time when Jim asked for Star Wars, give me the characters for Star Wars, the LLM actually didn't go through any sort of tools. It simply just answered. It generated the answer because it's such a popular thing that it was most likely in the training data set for that particular model that is used underneath Kira. Right? But in this case, right, this wasn't, so that's when it decided that this is potentially an obscure enough movie that it needs to use the tool to access it. It's non-deterministic, so there is no, it's not a rule that says, hey, first ask your tools and then do, if you can't, do the other thing. When the agent sends that particular prompt to the LLM is going to decide what is the best course of action. That's it. You have no control over that at that point. You might have control using steering documents and using the prompt itself. You could potentially tell it, hey, always look for this information in the tools before answering, or you can do that, but even then you don't have a full guarantee that it will do that, right? Fundamentally, what the LLM responds back is going to be relatively non-deterministic, right?
So let's, no, go ahead, there's a question.
This is an interesting topic. When doing stuff with MCP, is it possible to create sort of like a shadow of knowledge by having the agent select a specific MCP server to ask for a solution that it already would have access in the model, and so therefore you could make it not aware of certain things?
Maybe. Yeah, that's the answer. You can tell the MCP server to use certain tools, and within certain frameworks of building agents, you can define what some of the steps are in that. So for example, if you would be using something like LangGraph, you can define nodes that need to be transitioned through before it goes to the LLM for the decision. So in those situations, you could force a step at the beginning, hey, always look here, right, into this data set before you invoke the LLM. But that's not MCP that's enforcing that. That's not your tool that's enforcing that. That's the way you're building the agent itself that does that.
Yeah, a lot of that stuff, it's how do you force some determinism into something that's inherently non-deterministic, right? It's, you have to force it in some way. Right? And that's kind of what we're going to show here a little bit too, of like how do we lock down some of this data based off the user that's logged in, right? So, you know, if we look here at this titles table, there's 11 million entries in there. But, you know, for this one, we want to lock it down by the title type that, you know, Jim could only see title type of 1, that's movies. Vlad could see them all, and test 2 could see 1 and 5, right? It's like, we're using that for titles. A lot of times you might have a tenant ID or some other determining factor of who could see what data, right, based on some roles, right? So using that, we could see if we have this sort of where clause where title type equals any, because this is a Postgres array, right? We have 700,000 titles in there, movie titles, 1 in 5, we have 872,000 those. So it's like, that's kind of the where clause that we want to inherently have all the time. putting that something inside of the MCP server and being able to pass that thing there, it's like having the LLM put the right thing in there. We can never trust that. So we want to make it in a more deterministic way. So tools like Postgres have that ability. So what we want to do is use row-level security in order to be able to lock that down. So let's go do that. So what I'm going to do is set an environment variable inside of Postgres. So this way we could start building what we want for our policy to be. So there's a function called setConfig that'll set that. So this way now we could go here, and instead of having that string, we'll get the current setting. So now we set that to just having one, so that should match our 719,000 rows. So this way, now this is really the where clause that we want to set. So this way, based off what we set that RLS.types environment variable to, right, that where clause automatically gets appended to it. Create policy, RLS types on titles using. Let's copy and paste this where clause. Okay. Alter table titles. Enable row level security. Okay. Now, we are currently running as the table's owner, so row level security won't apply to that. So let's connect as the MCP user, not as the MCP owner. Right? Now, if we do just this one. So when we run that, you get nothing, because we have nothing set. So when you create your policy for something like row level security, you want to make it so this way, if things aren't set, you get no data. Right, so now we want to explicitly allow to be able to see some of that. So we'll go back and set the config here. Right, and now we could do that again without putting that where clause in there. Right, and we wait that, and now we get the right answer there. So row level security with Postgres will automatically add that in there. So when we're thinking about things like contexts like MCP or things where you're not quite sure what's going to happen as things get passed in there, we want to add that determinism in there, especially around securing your data. Things like if you're in the Oracle world, virtual private database, or things like that, there's other ways of doing that inside the database that we could be sure that's there. Right, so now let's use those tools that's there. So let's go into the movie server. So we'll go back to Hero. Change the... So what I'm going to do is to take in a command line parameter, because that's how this MCP server is taking things in through standard I/O. I'm telling it kind of what library to use. Value to call config right after making a database connection. Use the following as a template. You notice I'm always telling it to use a template, because I usually try these things, and then once I know it's going to work, I don't let it try to figure it out a second time. I just tell it how to do it. Right? Ends up being a lot faster that way instead of it trying to figure it out. Right. So, pulled that import in there, set that to none. Right after the connection, we're going to call that with the value that It gets passed in, yep, we're gonna allow that, merge that patch. And now it's parsing, get it in titles type, yep, we want that. Cool. So now let's go change parent directory to pass title types to the MCP server. Load entitled types from the users table when logging in. See what it does with that. It's always an adventure with this, seeing what it's going to, kind of code it's going to spit out at me. Right? It's you need to be able to look at things along the way. Yeah, we'll trust this. Yep. Wants to be able to go see that, sure. So added that into select, that's getting there. But that's coming back as a Postgres array. Python doesn't handle that so well. So change the query to cast titled types as a text. We want that coming back as a string so it's easier to pass around. Right? That one I've run through a bunch of times and run into a bunch of errors, so just save everybody the time that I know we have to cast that as a text. Right, now it's putting it in the session. Now it's passing in the args that are there, right? So this is another thing that I noticed, because this thing is in a different memory context there, it's not going to have access to that session, right? So this is another one of those things I keep bumping into, right? So change it. So entitled is passed to the args as a local variable. I haven't tried this prompt yet. We'll see what happens. I just know that that code that it spit out is going to be a problem. Right, there we go. We put it there, put it in there. That looks like it'll work a little bit better. All right. Cool. Now we got to go up one. There we go. This is taking a lot longer. Right? So, and it's not spitting out any movies or anything there because we have the row level security. We didn't change user app.py in order to handle the row level security. We're just passing it to the MCP server. At 429. So calling the tool, right? Couldn't find it. Right? It's because when we created DAT429, that movie, we set it as a type of a TV movie, not a regular movie, which has a code of 5 instead of 1. Jim only has access to titles of 1. So if we log in as Vlad, I stole your password.
Oh, no.
Now, Vlad has access to all the types. Still couldn't find it. Maybe that's a session thing. Tell this isn't a pre-cam demo because the cool stuff didn't run. Let's try this guy. See if that one works. Test 2. Still couldn't find it. So this sucker is locked down pretty good, right? Not quite sure where that's going, but there's being able to pass in the determinism here is something that the LLM isn't going to be able to do. That's why we're passing it in here through logging it in, right? So getting it there and then passing it in down here. So it's probably that I'm not passing it in through this entitled types properly, right? It's probably this sort of thing. Let's just put it here, and that's probably going to give us an error. But let's try that.
This is the point where I would honestly try logging. See what the variables are, or
Try mocking.
Yeah.
Yeah. Yeah, we could, but we only have a few minutes left. So going ahead and trying to go through that and having it go do all that is it is a little finicky about how you pass some of that through. Yeah, there's the error. So that's the error that I was trying to avoid, right? Where I can't find that key, the missing key here. Right. So that comes down to Python Streamlit stuff that I don't really want to debug in front of everybody here because I don't know where that's going to go. And if we ask Kiro, it's going to go off into little tangents. But the main idea there of using row-level security in order to lock down your data, because that's the deterministic part. If the LLM is passing something that's there, it has policies that, as you can see, you get no data if it's sending things in the wrong way. That's what you want the default to be, is don't expose out your data in some sort of way. You'd rather it get no data than putting out the wrong data. As we're using these tools and it's moving faster and faster, we have to remember good security practices around our data and the privacy and the aspect of that. So it means leveraging the features inside the database in order to be able to do that, because those are the deterministic parts. If we added another parameter to the tools that's passed in, like the user ID or the entitled types, maybe the LLM will put it in there right, maybe it won't, right? It might just say, hey, I want access to all the movies, so then it'll try to log in as Vlad. Right? It's like it'll pass in a random string that'll give you all the things that are there. Right, that's the main thing that's there. Let me flip back over here. So as we get that QR code goes to the GitHub repo, that I'll post this code that's up there. I will get it working, right, with that last little bit. And I'll leave comments in the code of what I changed from what we have here in our session. So this way everybody can see that's there. What did it quite do wrong with passing that thing and that entitled types parameter across? But for folks of doing that, you'll be able to see it and you'll be able to run everything. I'll also have scripts on how to create the database, so downloading the files, being able to recreate everything that we did. It'll be in that GitHub repo probably Monday morning. When you're doing it in a development environment, we saw a lot of the loops as we were going here, but if that was your main production application, you have basically the internet doing there that all of a sudden, if they ask questions, all of a sudden your bill goes through the roof. Yep. You have no way of determining that, right? It's like it becomes a problem. So like Vlad said, it's if you're sure you're going to need that context every time, just add it. Yep. Right? Vlad and I did a code talk last year about RAG, where it was more deterministic of doing some of that stuff, where we took movies, created a JSON document, putting vectors on it, and then used that for semantic, for nearest neighbor searches and stuff like that, for semantic searches, was more deterministic than this, but it was less flexible because we had to pre-can all the vectors ahead of time. So if we were going to add the movie, we had to go create the vector of that new movie, put it inside the database in order for it to find it. This is just using standard SQL. Thank you, everybody. Please fill out the survey. It really helps us in order to make everything better for you. So please fill out the survey and leave some comments for us. Even if it just says hi, that would be cool too. Appreciate it. Thanks, everybody.
Thank you all.